Have you ever seen something so real, so impossibly beautiful, that for a moment you forgot it came from our own solar system? Because what you're about to witness are not animations, not CGI, not artist impressions. These are real photographs captured by our spacecraft, raw, unfiltered windows into worlds we were never meant to see with human eyes. Think about this. A storm on Jupiter so massive it could swallow Earth whole, swirling in colors no artist could ever dream of. A crack on an icy moon that might be hiding a secret ocean, and possibly life. A volcano erupting in real time on the moon of Jupiter. A perfect frozen heart etched onto the surface of Pluto, 4.7 billion kilometers away. And a photograph taken from the edge of the solar system, showing Earth as nothing more than a pale dot. Every human story condensed into a single pixel. But the most shocking image, the one that changed our understanding of the solar system forever, is still coming in this video. So sit tight. What you're about to see is the truth of our cosmic neighborhood, exactly as it looks. Why real images matter. In a world filled with digital effects, AI-generated visuals, and artistic recreations, it's easy to forget one simple truth. Real images from our solar system are incredibly rare. Most of the pictures we see online, the dramatic planets, the colorful nebulae, the glowing stars, are often enhanced, simulated, or completely illustrated to help us visualize what our naked eyes could never see. But a true spacecraft-captured image? That's different. That is a direct message from another world, a real photon traveling across empty space, hitting a camera built by human hands, and bringing back evidence that these places truly exist. Artist illustrations help us imagine, computer simulations help us understand, but real images help us believe. And that's why missions like Voyager, Cassini, New Horizons, Juno, the Mars rovers, the Hubble Space Telescope, and the James Webb Space Telescope are so important. They are our eyes in the darkness, traveling millions, even billions of kilometers, powered by nuclear generators, protected by layers of shielding, carrying cameras that can survive radiation levels that would destroy most electronics on Earth. When Voyager turned its camera back and captured the pale blue dot, when Cassini slipped between Saturn's rings and sent back that impossible photograph, when New Horizons revealed Pluto's heart-shaped surface for the first time, those weren't guesses, those weren't paintings. Those were real places, captured by real machines, doing the impossible. And in this video, every single image you'll see comes directly from a spacecraft or a telescope. No fakes, no edits, no simulations. This is our solar system, exactly as it looks. The Sun. Capturing images of the Sun may seem easy, considering it's the nearest star to us. However, in truth, the Sun is among the most challenging objects in the solar system to photograph directly, as it is incredibly bright, highly violent, and extraordinarily powerful, causing a standard camera to overexpose instantly. This is why we depend on focused missions such as NASA's Solar Dynamics Observatory (SDO) and the Parker Solar Probe. These spacecraft are not capturing typical images. They are recording the Sun in ultraviolet, extreme ultraviolet, and wavelengths invisible to our eyes, exposing a surface that resembles a vibrant, pulsating ocean of flames. Examine a genuine SDO up close, and you'll observe something peculiar. The Sun is adorned with granules, large bubbling cells of plasma. Each granule is about the size of Texas, rising and falling like boiling water, except the water is 5,500 degrees C, hydrogen plasma. This is convection at a scale we can barely comprehend, and SDO captures it in astonishing detail. Then there are solar flares, sudden eruptions where magnetic fields snap and release energy equivalent to millions of nuclear bombs in seconds. Real images show these flares shooting out into space, accompanied by prominences, loops of glowing plasma that arc thousands of kilometers above the Sun's surface. Some loops are so massive that Earth could fit inside them several times over. But the most extraordinary milestone comes from the Parker Solar Probe, humanity's first spacecraft to literally touch the Sun. In 2021, Parker flew through the Sun's outer atmosphere, the corona, surviving temperatures of over 1,000 degrees with a revolutionary heat shield. For the first time in history, we are receiving real images and data from inside a star's atmosphere, something that was once pure science fiction. Every picture you see of the Sun from these missions is not just a photograph, it's a reminder of how fragile our technology is and how bold humanity has become. Our star is beautiful, terrifying, and unimaginably powerful, and we are finally close enough to witness it for real. Mercury. Mercury may be the closest planet to the Sun, but for most of human history it remained almost completely unknown. The reason? Trying to photograph Mercury is like trying to take a picture of a black rock sitting right next to a floodlight. Its tiny size, extreme brightness on one side, and pitch black darkness on the other made it nearly impossible to see clearly from Earth. Everything changed when Mariner 10 flew by Mercury in the 1970s, capturing the first ever close-up images of its surface. For the first time, we saw a world that looked strangely familiar, covered in craters like our moon, yet hiding mysteries our moon never had. Then came NASA's Messenger mission in 2011, which orbited Mercury and revealed details so sharp they stunned scientists. Messenger's real images showed a planet of brutal extremes, daytime temperatures hot enough to melt lead, and nighttime temperatures colder than Antarctica. Mercury's thin atmosphere can't hold heat, making it the most thermally unstable planet in the solar system. But the biggest surprise came from the discovery of hollows, bright, shallow depressions scattered across Mercury's surface. These hollows don't exist anywhere else in the solar system. They may be formed by volatile materials inside Mercury literally evaporating when exposed to sunlight, a process so strange that scientists had to rethink Mercury's composition. And then there's the Caloris Basin, one of the largest impact basins in the entire solar system. A massive asteroid slammed into Mercury billions of years ago, carving out a crater more than 1,500 kilometers wide, so large that entire mountain ranges rose at the opposite side of the planet from the shock. Photographing Mercury was once thought nearly impossible. But thanks to Mariner 10 and Messenger, we can now see this scorching, battered world exactly as it is, a survivor forged in fire and impact. Venus, our nearest planetary neighbor, is often called Earth's twin, but looks can be deceiving. Shrouded in thick clouds of sulfuric acid, its surface is completely invisible to conventional cameras. No telescope from Earth, no matter how powerful, can pierce the haze. So, how do we see what lies beneath? The answer: radar. NASA's Magellan spacecraft, which orbited Venus in the 1990s, became our eyes beneath the clouds. Instead of light, it used radar waves to bounce off the surface, mapping mountains, valleys, and vast plains in remarkable detail. The result? Real, high-resolution images of a world hidden for centuries, revealing canyons, craters, and volcanic structures. Long before Magellan, the Soviet Venera landers braved Venus's hellish conditions. They sent back the first real photographs of Venus's surface in the late 1970s and early 1980s. The images show rocky, desolate plains under a dim, reddish sky. Nothing like the cartoonish, lava-filled worlds imagined in science fiction. Surviving on Venus is no small feat. Surface pressure is 90 times that of Earth, like being a kilometer underwater. Temperature hot enough to melt lead and fry most electronics. Many spacecraft didn't last long. Venera landers only survived a few hours, yet even that was enough to capture invaluable images. And Venus is not just a dead world. Recent studies have detected signs of volcanic activity, hinting that the planet is still geologically alive. Some lava flows may have occurred within the last million years, meaning Venus is more dynamic than we ever imagined. From radar maps to the first landing photos, Venus challenges our assumptions and reminds us the solar system still holds secrets even in plain sight. Through courage, ingenuity, and radar technology, we now have a window into a world that was once completely hidden, a world both familiar and utterly alien. Earth. Sometimes the most extraordinary images are the ones closest to home. Earth, the only planet known to harbor life, has been captured in photographs so iconic that they've reshaped our perspective on the universe. The blue marble, taken by the Apollo 17 crew in 1972, was one of the first full-disk images of Earth from space. It showed a vibrant blue planet, swirled with white clouds and brown-green continents, floating alone in the blackness of space. A few years later, the famous Earthrise photo from Apollo 8 gave humanity a profound perspective, the fragile Earth rising above the barren lunar surface, a tiny oasis in an endless void. Today, we have satellites like DSCOVR Deep Space Climate Observatory, providing continuous, real-time, full-disk images of Earth. From 1.5 million kilometers away at the L1 point, DSCOVR captures stunning, detailed photographs of weather systems, oceans, and continents, true living portraits of our planet. These images are more than just beautiful. They are reminders of our fragile home. From space, national borders vanish, oceans blend into clouds, and the vastness of the universe frames our tiny planet. Every photo tells the same story. Earth is unique, precious, and worthy of protection. Seeing our planet from this perspective, with its swirling clouds, endless blue oceans, and continents suspended in space, is both humbling and awe-inspiring. It's a vision that unites all of humanity, reminding us that despite our differences, we all share this tiny blue marble. The Moon. The Moon has fascinated humanity for millennia, but it wasn't until the Apollo missions that we finally set foot on its surface. The iconic Apollo photographs captured astronauts walking across grey regolith, planting flags, and gazing back at Earth. These images remain some of the most instantly recognizable real photos from any celestial body, offering a tactile, human connection to another world. After Apollo, NASA continued to study the Moon in unprecedented detail with the Lunar Reconnaissance Orbiter (LRO). Orbiting just 50 kilometers above the surface, LRO's cameras map craters, mountains, and mirror the vast, dark plains formed by ancient volcanic activity. Its high-resolution images allow scientists to study landing sites, monitor geological changes, and even spot the paths of the Apollo rovers decades later. Meanwhile, China's Chang'e missions have expanded our view, capturing the far side of the Moon, which is never visible from Earth. Chang'e images reveal a heavily cratered, rugged terrain, providing insights into the Moon's history and formation. These real images showcase features like the Tycho and Copernicus craters, massive impact scars with central peaks, and the contrast of smooth maria against jagged highlands. One of the most poetic views of the Moon comes from Earthshine. Sunlight reflected off Earth illuminating the dark portion of the lunar surface. This subtle glow, captured in LRO and Apollo photos alike, reminds us of the intimate connection between Earth and its satellite. From the dusty Apollo landing sites to the untouched far side captured by Chang'e and the detailed maps from LRO, these real images let us explore the Moon like never before, a world both familiar and mysteriously alien. Mars. Mars has long been the crimson gem of the night sky, a planet that has fascinated humanity for centuries. However, it was only when spacecraft started orbiting and landing on its surface that we genuinely perceived Mars as a realm of extremes, beauty, and captivating clues of past life. The voyage started with the Viking missions during the 1970s, delivering the initial vivid, authentic images of the Martian terrain. Subsequently, the Pathfinder mission in 1997 provided us with the initial color panoramas, displaying rocky landscapes, dust-laden plains, and the foundations of our comprehension of Martian geology. Next arrived Spirit and Opportunity, paired rovers that investigated different areas of the planet for many years. Their authentic images showcased towering dust storms, vast sand dunes, long-standing riverbeds, and stratified rocks that hinted at a more humid history. Opportunity's last image of the Endeavour crater serves as a poignant reminder of the enduring nature of these missions. The narrative progressed with Curiosity, a mobile laboratory that not only takes breathtaking high-resolution color photographs, but also examines rock composition on site. It has shown that Mars previously had environments conducive to microbial life, with ancient lakes and chemical indicators retained in rock strata. Currently, Determination extends the boundaries further. Fitted with cameras and microphones, it captures video and audio from the surface of Mars, marking the first occasion humans have experienced the sound of wind howling on another planet. The Ingenuity helicopter, its counterpart, has undertaken several flights, exploring the landscape and presenting Mars from an unprecedented viewpoint. Each picture narrates a tale: the crimson dust that colors the dunes, the gentle radiance of Martian sunsets, the traces of long-gone water pathways, and the faint suggestions that life might have previously thrived in this place. These images represent more than mere scientific information. They serve as a link uniting humanity with another realm, a documentation of discovery that expands with each rover, every flight, and every pixel sent back to Earth. Mars, the second most photographed planet following Earth, is showcasing its full splendor, a desolate yet stunning world, rich with the history of water, wind, and the potential for life. Jupiter. Jupiter, the colossal entity of our solar system, is a planet that challenges imagination. Its striking cloud formations, turbulent storms, and vast size create a realm of extremes, and capturing its splendor is no easy task. Due to NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, we have finally observed this gas giant in extraordinary detail. Juno's actual images display cloud formations that twist and spiral like liquid marble, showcasing hues from rich browns to vivid whites and reds. The legendary Great Red Spot, a tempest bigger than Earth that has persisted for centuries, has been captured in detail, revealing its intricate turbulence and sophisticated vortices that were once unseen. Beyond the equator, Juno has documented Jupiter's poles, showcasing a tumultuous configuration of storms that cluster into shapes that occasionally seem hexagonal or polygonal, unlike any observed in the solar system. These pictures depict storms colliding, combining, and twirling in captivating designs, offering us fresh insights into the Earth's atmospheric behavior. Taking these photos was a significant hurdle. Jupiter's powerful radiation belts can damage spacecraft electronics in a matter of hours, but Juno's cameras and instruments were protected and reinforced to endure this harsh environment, enabling us to view the planet's characteristics in remarkable detail. Juno has additionally delivered authentic images of Jovian lightning strikes streaking across dense cloud layers and auroras glimmering at the poles. These phenomena, undetectable by human eyes from Earth, are recorded in various wavelengths, exposing energy interactions between Jupiter's atmosphere and its magnetic field. Each image from Juno offers a view into a realm far beyond our understanding, a vibrant planet filled with storms, lightning, and magnetic forces, all portrayed with accuracy and elegance. With Juno, we are able to experience Jupiter not merely through imagination, but in its full dynamic, chaotic, and stunning splendor. Saturn. Saturn has always been celebrated for its magnificent rings, yet it was NASA's Cassini spacecraft that revolutionized our perception of this gas giant into a visual marvel. From 2004 to 2017, Cassini orbited Saturn and took high-resolution images that unveiled a planet marked by elegance, intricacy, and ongoing activity. The rings, observable from Earth with a small telescope, were revealed by Cassini to have a complex structure made mainly of ice grains along with some rock and dust. The rings exhibit waves, voids, and strands resulting from gravitational effects with Saturn's moons. Cassini uncovered features such as the Encke Gap and Keeler Gap, where small moons create channels in the rings, transforming them into vibrant, dynamic entities. Outside the rings, Saturn's atmosphere turned out to be equally striking. Cassini captured enormous storms that can stretch for thousands of kilometers, generating lightning and chaotic cloud formations. A well-known image depicts a massive hexagonal storm at Saturn's North Pole, a consistent aspect of this extraterrestrial realm that resists straightforward interpretation. Cassini provided us with artistic views of Saturn, such as the backlit image called "The Day the Earth Smiled," where sunlight highlights the rings and a distant Earth is seen as a tiny point. This famous image reminded people of our position in the universe while displaying the stunning geometry and transparency of the rings. Cassini's intricate imaging has also aided scientists in examining ring composition and development. The particles, rich in ice, reflect sunlight spectacularly, producing the radiant bands observed in actual images, while slight color variations suggest differences in age and particle size. Cassini demonstrated that Saturn's rings are not fixed. They are dynamic, constantly evolving, and much more intricate than once thought. Through real images captured up close, we can see the elegance of its rings, the fury of its storms, and the delicate play of light and shadow that makes Saturn the most huygens planet in our solar system. Saturn's moons. Saturn is renowned for its rings, but its moons are just as intriguing, and due to NASA's Cassini-Huygens mission, we now possess authentic images showcasing their otherworldly terrains. We will begin with Titan, the largest moon of Saturn. Titan is shrouded in a thick orange mist, an atmosphere primarily made up of nitrogen, along with some methane. This dense mist rendered it almost impossible to capture images of the surface until the Huygens lander arrived in 2005, transmitting actual pictures from the surface. These images unveiled riverbeds, dunes, and lakes brimming with liquid methane and ethane, a realm strangely reminiscent of Earth in its water cycle, yet completely foreign in its chemistry. The lander recorded the faint shimmer of Titan's hazy orange atmosphere, revealing a terrain shaped by winds and moving hydrocarbons instead of water. Next comes Enceladus, a smaller yet equally remarkable moon. Cassini found geysers of water vapor and ice particles erupting from cracks close to its south pole, launching plumes hundreds of kilometers into space. Actual images obtained by Cassini display these icy jets lit by sunlight, producing one of the most visually stunning occurrences in the solar system. The geysers suggest a hidden ocean beneath Enceladus's icy surface, sparking intriguing prospects for microbial life distant from Earth. Titan and Enceladus exemplify the variety and intricacy of Saturn's moons. Titan's methane-laden, orange-tinged landscapes and Enceladus's icy, vibrant surface demonstrate that even small moons can possess lively environments. The images returned by Cassini and Huygens are more than mere pictures. They offer glimpses into extraterrestrial realms, showcasing liquid lakes, freezing geysers, and atmospheres that are unique compared to Earth, while broadening our comprehension of what moons in our solar system could be. These moons remind us that even beyond the giant planet itself, Saturn's system is a treasure trove of real, breathtaking, and sometimes life-hunting imagery. Uranus and Neptune. The farthest planets in our solar system, Uranus and Neptune, continue to be among the most enigmatic realms, primarily due to their infrequent observations. In contrast to Jupiter and Saturn, which have had several visits from orbiters, Uranus and Neptune have only been closely photographed a single time, by Voyager 2 during the 1980s. Voyager 2's encounters offered the first and only detailed images of these icy giants, showing planets that appear deceptively serene from Earth telescopes, but are actually realms of intense weather and distinctive characteristics. Voyager photographed the Great Dark Spot on Neptune, a gigantic storm similar in size to Earth. Winds around this storm blow at speeds of 2,100 kilometers per hour, making Neptune the windiest planet in the solar system. The pictures displayed vibrant clouds and intricate atmospheric formations that still captivate scientists currently. Uranus, on the other hand, is distinct due to its angled rotation. It essentially rolls nearly on its side, with its axis inclined over 97 degrees. The images from Voyager 2 showed a delicate ring system, gentle cloud formations, and a light blue-green atmosphere tinted by methane that absorbs red light. Its significant tilt leads to atypical seasonal variations that we are just starting to comprehend. The explanation for the scarcity of genuine images of these planets is straightforward. They are distant, with Uranus approximately 2.9 billion kilometers from Earth and Neptune exceeding 4.5 billion, making it extremely difficult and costly to deploy orbiters or landers. Consequently, Voyager 2's photos continue to serve as invaluable glimpses into these far-off realms, highlighting how much of our solar system is still uncharted and enigmatic. Despite contemporary telescopes and space explorations, Uranus and Neptune remain mostly unobserved in detail, making each authentic photograph a valuable find for scientific research. Pluto. For many years, Pluto appeared as a remote, blurry speck of light at the boundary of our solar system, a planet enveloped in enigma. Everything transformed on July 14, 2015, when NASA's New Horizons spacecraft conducted its landmark flyby, returning the first ever high-resolution images of this small, icy dwarf planet. One image, in particular, fascinated both scientists and the public: the heart-shaped area, officially called Tombor Regio, in tribute to Pluto's discoverer, Clyde Tombaugh. The heart is an expansive field of luminous, mirrored ice, standing in stark contrast to Pluto's more shadowy, rough landscape. Pluto's distinct shape and luminosity quickly transformed it into a cultural and scientific symbol. New Horizons showed that Pluto is not a lifeless, frozen planet. The Tombor Regio consists of glaciers made of nitrogen ice, gradually moving across the surface in a manner akin to Earth's glaciers, but at temperatures reaching as low as 229 degrees Celsius, 380 degrees Celsius. These glaciers modify Pluto's terrain, forming characteristics that were completely surprising in such a small and faraway celestial body. Images of Pluto astonish scientists for several reasons. Its varied geology, featuring mountains, plains, and ice flows, indicated internal heat and geological activity, opposing the idea that such a small, frigid world would be completely frozen and lifeless. The existence of active glaciers and possible convection patterns questioned long-standing beliefs regarding the the evolution of small planets over billions of years. The heart-shaped area is not merely a picture, it serves as proof that even at the distant boundaries of our solar system, celestial bodies can be vibrant in ways we never envisioned, prompting us to reconsider what we understand about small frozen worlds. Beyond Pluto. Beyond Pluto extends a frozen boundary called the Kuiper Belt, which contains numerous small icy objects left over from the solar system's formation. In January 2019, NASA's New Horizons spacecraft delivered to humanity the first ever close-up photographs of a Kuiper Belt object, KBO, Arrokoth, formerly known as Ultima Thule. The pictures displayed a remarkable snowman form made up of two connected lobes. The bigger lobe spans approximately 21 kilometers, whereas the smaller lobe is about 15 kilometers in size. This bilobed form indicates that Arrokoth originated from the gradual joining of two distinct bodies in the early solar system, a method that retains insights into the initial phases of planetary development. Arrokoth's surface looks smooth and minimally cratered, suggesting it has stayed fairly constant for billions of years. Its vivid, reddish color results from intricate organic compounds indicating the chemical essentials found in the outer solar system. These actual images represent much more than mere photographs of a faraway stone. They offer a glimpse into the early days of the solar system, revealing how small objects came together, impacted, and combined in a relatively tranquil setting. Examining Arrokoth allows researchers to understand the formation of planets and other celestial objects from the ancient disk of gas and dust, a narrative etched in ice billions of kilometers away from the Sun. For the first time, we can observe the icy remnants at the boundary of our solar system, reminding us that even the tiniest planets have significant tales to share. Voyager's final photographs. By 1990, Voyager 1 had journeyed over 6 billion kilometers from Earth, nearing the far reaches of the solar system. Prior to shutting its camera down for the last time, Voyager was instructed to turn around and photograph our home planet. The outcome, a solitary dim speck of light held within a sunray, Earth as a pale blue dot. From billions of kilometers distant, oceans, continents, and people were imperceptible. However, this minuscule point, hardly a pixel in the enormity of space, contains all that we understand, all that we cherish, and everyone we've ever encountered. It's Earth, drifting in a ray of sunlight, a delicate refuge in the vastness of the universe. Carl Sagan, who brought this image to prominence, contemplated its significant meaning. Observe that dot once more. That is present. That's where I belong. That is us. On it, all those you care for, all those you're familiar with, everyone you've ever known, lived their lives. The pale blue dot image transcends being a scientific achievement. It serves as a poetic reminder of our position in the cosmos. It invokes a sense of humility, awe, and duty, illustrating humanity portrayed not in statues or charts, but as a tiny dot in the vast cosmic sea. Even years later, this image still motivates us, serving as a reminder that in spite of our differences, we inhabit a small, delicate world collectively. Voyager's last images extend beyond mere photographs. They deliver an eternal message from the boundary of the solar system, urging us to value our planet. The future of real solar system images. The tale of exploring the solar system is not yet complete. Even with missions such as Voyager, Cassini, New Horizons, and Juno providing stunning images, the upcoming decade is expected to bring even more incredible actual photographs from far-off worlds. NASA's Europa Clipper, set to launch in the mid-2020s, will circle Jupiter and investigate its frozen moon, Europa. Using high-resolution cameras in conjunction with radar technology, Clipper seeks to obtain detailed images of Europa's icy exterior, its cracks, and possible plumes, providing the initial thorough examination of an environment that could contain subsurface oceans suitable for supporting life. NASA's Dragonfly mission is set to launch in the late 2020s, bound for Saturn. This cutting-edge rotorcraft helicopter will soar over Titan's methane-abundant terrain, taking authentic pictures of dunes, lakes, and organic chemical structures, offering a unique view of Saturn's largest moon. Europe's JUICE, Jupiter Icy Moons Explorer mission is set to orbit Jupiter beginning in 2031, focusing on Ganymede, Callisto, and Europa. JUICE will provide high-resolution color photos of these frozen moons, studying their surfaces, possible oceans, and geological activities, enhancing the findings obtained by Clipper. At the same time, humans are going back to the moon through the Artemis program. Astronauts from Artemis and lunar orbiters will take actual images of the moon's poles, deep craters, and areas that are always in darkness, creating a new, comprehensive visual database of the lunar terrain. Collectively, these missions ensure a transformation in authentic solar system visuals. In the next 10 years, we will see high-definition, true-color images of icy moons, foreign landscapes, and active planetary surfaces, boosting scientific knowledge and public fascination. From Europa's frozen surface to Titan's golden mist, our comprehension of the solar system will become deeper, more intricate, and more fascinating than it has ever been. The outlook for space photography is promising, countless billions of kilometers away, yet there are no boundaries to what we can photograph. Our exploration of the solar system has revealed places that are both known and completely foreign, from the blazing surface of the Sun to the frozen terrains of Pluto, from Titan's orange fog to Jupiter's churning tempests. Every picture you viewed in this video was taken by actual spacecraft, not computer-generated images or artistic renderings, providing a genuine look into the universe we live in. However, this is only the start. The solar system is immense, and future missions such as Europa Clipper, Dragonfly, JUICE, and Artemis are set to provide us with more stunning, factual images that will push our comprehension and ignite our creativity. If you've experienced awe, curiosity, or wonder on this journey, picture what is coming next: fresh discoveries, concealed terrains, and tales inscribed in ice, rock, and gas, ready to be revealed. Stick with us, as on this channel, each video is based on actual science, authentic images, and the newest studies aimed at motivating and informing. Tap subscribe and check out our upcoming videos. Let's keep discovering the universe together, one authentic image at a time, and nurture the curiosity that defines us as human.